Good afternoon, everyone. Am I audible? Good afternoon. I am Sagarika Patnaik, coordinator for today's SOAWAL lecture series 21. A very warm welcome to everyone. I welcome our HOD, Professor Debahoti Mishra, and all those who are present here. Today we have with us Dr. Mangubala Bisi as our speaker. She is working as a, let me have a brief introduction of our speaker. She is Dr. Mangubala Bisi, working as Assistant Professor in the Department of Computer Science, NIT Warangal. She received her PhD degree from IIT Kharagpur, MTech degree from NITTR Kolkata, and BTech degree from North Orissa University, Odisha. Her research interest includes software engineering, software reliability, modeling and prediction, machine learning, soft computing techniques, and optimizing techniques. She has received 2 academic awards: University Silver Medal in MTech, Multimedia and Software Systems, and Gold Medal in BE Computer Science and Engineering for Best Graduate in her academic career. She has published papers related to software reliability, prediction, using machine learning applications in reputed international journals and conferences. She has also published an international research reference book on artificial neural network applications for software reliability prediction. She has conducted FDPs on machine learning and computing techniques for engineering applications and optimizing techniques in engineering applications in NIT Warangal. A very warm welcome, ma'am, Dr. Mangubala Bisi. Before we go to the topic of today's topic, let us have a short tour of our university. This was a short tour of our college. Ma'am, Dr. Mangubala Bisi, you can start.
Yeah, thanks, Dr. Sagarika. Am I audible?
Yes, audible.
Okay. Thanks for giving a nice introduction to this gathering as well as showing the virtual tour of your university. I also like to thank the organizing team of this lecture series and HOD Department of CSE and the coordinator Dr. Sagarika for giving me an opportunity to deliver a talk in this webinar. So I think this series is for UG, PG and PhD level students. So I have selected a very simple topic so that the students can get some idea whenever they want to solve any problem using machine learning. So let me share my screen. Is my PPT visible? Hello. Anybody please confirm whether my PPT is visible? Okay, so we are going to discuss about these basic concepts in the machine learning, that is the outlier and the class imbalance issue. So what are the different types of problems that can arise with this outlier and the class imbalance, right? If you are having some data and these two problems are there in your data, how to handle them so that you will get some better accuracy or better performance of your machine learning models, right? Nowadays, if you see from the BTech level or the UG level, PG level or the PhD students, right? Everybody wants to work with machine learning. Everybody wants to solve their problems in various domains, right? It may be your networking, it may be cloud computing, it may be software engineering, it may be related to your what you call that is the distributed computing. Right? Whatever domain related to the CSE or other allied branches, everybody wants to solve the problem by using the machine learning model. So what we are doing in the basic machine learning model, so we are having some data, some historical data is there, right? We are trying to learn or we are trying to train a model so that it will predict better in the future. So for that we want the historical data, right? So we have to either we have to collect the data if the data is available in some source, or if the data is not available, we have to generate the data, right? That may be generated data or that may be your existing data. So data is the main thing whenever you want to apply any machine learning model, right? So we'll see how these basic concepts, this outlier and class imbalance, they may affect the performance of the machine learning model and how we are going to handle these two problems, right? So basically the outline of the talk is like this. So we'll see what is the outlier, how it is going introduced into the data set, what are the different types of outlier, how to detect the outlier, and if you are able to detect the outlier, how to prevent the outlier from your data. And the second part, in the second problem, we'll see what is the class imbalance issue, right? And what is historical data and how to resolve this class imbalance issue from your data. So for that, we'll see some basic techniques, three techniques only because due to time limit, right? Because 40 minutes has been allotted to me. So within 40 minutes, I think we can discuss these topics so that I will give some research references so that if anybody wants to, right, if you wants to solve your problem, you have to choose some hybrid models for this imbalance issue and you can make your data balanced. So coming to the outlier concept, right? Suppose we are having some data, we want to, suppose we want to store the age of our BTech. Suppose we will talk about the BTech final year students and we are storing the data or we are maintaining a record of the BTech final year students with their age, right? Maybe roll number, age, marks, right? Or the percentage, CGPA, whatever. Many attributes are there. So let us discuss one attribute, suppose age, right? So we are storing the age of BTech final year students And suppose we are analyzing the data, we are getting a record of, right, record where your age is maybe 50, right? We are assuming that our BTech final year student may be maximum 21 to 22 as is there, right? So if you are having a age of 50, right, so that behavior of that record will be different from the remaining records in the data, right? So that record having the age 50, that you can call as an outlier, right? So basically, if you come to the statistics in the mathematical point of view, so outlier, this is an observation that is distant from other observation, and that outlier behavior, right, that is different from all the remaining points in the data set, or you can call all the remaining records in the data set. So why this is coming? Because there is large deviation between all the remaining data and this age 50, right? So you can define the outlier. This is an object deviates significantly from the rest of the objects in your data, right? So basically, whenever you want to solve a problem, we are collecting the data. So before applying any machine learning model, you have to analyze the data, right? And you have to analyze for this outlier. So basically, this outlier, right, this is coming under your pre-processing step whenever you are designing any machine learning model to solve a problem. So you have to analyze the outliers, and that is called your outlier analysis or outlier mining. So how to do this analysis for this outlier, right? Now let us see how these outliers are getting introduced into the data sets, right? So when these outliers are getting introduced, whenever we are gathering the data or we are collecting the data. So as you know, right, data can be collected in many ways. It depends upon the problem, which problem you want to solve, which data you want, right? So it may be collected doing different interviews. You can do different questionnaires. You can do different survey related to that problem. You can observe some observations. From that observations, you can collect the data, right? You can view some documental records, right? You can do some group discussion, some oral history, or now in this technology era, right? Our sensors, we are using different types of sensors to generate data for us. So whenever we are collecting the data through these different types of techniques, your outlier may be introduced into the data set. Right? So another case may be, right, whenever we are, suppose we are maintaining some record, so we are entering data into the database, right? So due to incorrect entry also, outlier may be introduced into the data set. Or it may be due to the misreporting of data, right, or misreporting of observation, or whenever your actual data is not there, you are generating the data, right, by using some sampling process. Or suppose I want the data which follows some normal distribution, right? We have to sample that data. So during that sampling errors also, your outlier may be introduced into the data set, right? So as a whole, what you can call outlier, that is nothing but the mistake, whatever mistake you are doing during the data collection or the data gathering. So what it represents with respect to the statistical view, it represents the indication of variance in your data, because that outlier points, they are significantly deviated from the remaining points. So this variance will be more here, right? So due to this, whatever machine learning models are designed, right? So that performance of the machine learning models, it may degrade. So you have to handle this outlier when before using any machine learning model, right? So basically, there are three types of outlier: your point or global outlier, contextual or conditional outlier. Third one is your collective outlier. So from the name, you can know what is the point of the global outlier. So that is a specific point. If your data, right, if you are having the data having 100 points or 100 objects or 100 records, so one point, one object or one record, that can be deviating, right, from the remaining points. So that single record we can call as a point of the global outlier. And the contextual or conditional outlier, with respect to a particular condition, a given record may be called as an outlier. But if you consider another condition, it may not be considered as an outlier. And the third one, that is the collective outlier. So in the collective outlier, instead of taking a single point or single record, we are taking a group of, right, we are collection of records, and those collection of records, they are having, right, or they are deviating from the remaining records. So those collection of points we can call as a collective outlier, right? So from the name we can understand these things. So point of the global outlier. So this is a point is considered a global outlier if its value is far outside the entirety of the data in which it is found. right? So that as example I have given, right? That 50, suppose we take final year student, we are maintaining the age and we are getting 50, 100 something, right? So that is the point of the global outlier in our data. So that we have to observe. Second one is the conditional outlier that we see. Suppose with respect to some condition, a data point is said to be a contextual outlier, right? So that is also a point of the global outlier, or it may be the collective outlier also, right? Both things can occur in the contextual or the conditional outlier. If you see, right, our world economy falls drastically due to the COVID-19 in 2020. If you analyze the economic status of world, right? So due to this COVID-19, in the 2020 or 2021, our economic falls down. So that is due to this COVID-19 condition also, right? So that the things we can consider the contextual or the conditional outlier in your data. And the collective outlier, as I told, is a group of records or a collection of observations you have to consider, right? So those collection of observations, they are anomalous, but appear close to one another because they have a similar anomalous value. Suppose you think, right, because I am doing work in the right software reliability prediction, right? Suppose I want to analyze a program. I have written a program and I want to analyze the cyclomatic complexity of a program, right? Suppose we know that if the cyclomatic complexity value is greater than 10, the program is very complex, right? Suppose I am maintaining 10 different softwares and I am maintaining the cyclomatic complexity value as an attribute for the data. Suppose for 1,000 data points, so the 1,000 records, maybe 100 records, they are having the CC value less than 10, and the remaining, right, 900 records, they are having the CC value like very high value, 20, 50, 70, 75, 100, like that, right? So there I can cap that value, right? Because above 10, if the cyclomatic complexity value is above 10, their behavior is same. We are assuming that the software is complex only. So that 20, 50, 70, 75, whatever we are getting above 10, those points, right? We can fix that value, or those points we can call, those are the collective outlier, because their behavior is similar with respect to the remaining points. So as a collective, right, as a collection, they are deviating significantly from the entire data set. So that is called your collective outlier. Basically, whenever you are collecting the time series data, right, in the time series data, this type of collective outlier we will observe. So whenever you are processing any time series data, suppose any COVID-19 data you have collected and you want to do some research on this COVID-19 data, so in that case, you have to analyze this collective outlier. Now, how to identify, right? And what is the requirement of identifying the outlier, and how to identify this outlier from your data? So as we know, the machine learning algorithms are very sensitive to the range and the distribution of attribute values. So that is the nothing but the variance in our data, right? So whenever outliers are present in our data, the variation in the attribute values are very high, right? So it may spoil and mislead the training process of the machine learning model, right? Due to which it will take longer training times, right? Your less accurate models, and ultimately your poorer result. That means your performance of the machine learning model, it may degrade due to these outliers. So if this is the importance, right? So we know this is the importance of outlier in the machine learning, right? So how to identify or how to detect these outliers from your data? So basically there are two simple things you have to do here. Either you can go for the visualization technique, or you are going for the mathematical function, right? So in the visualization technique, you have to plot some graph, and from that graph, you can identify which points are called the outlier in your data set. And in the mathematical function, you have to do some mathematical calculation, and you have to find out, right, which points are outlier in your data set. So under visualization technique, you can go for the box plot, you can go for the histogram, you can go for the scatter plot, right? And under the mathematical function, you can go for the z-score value calculation for your data, or you can go for the interquartile range, that is the IQR score. By using these 5 things, any one you can follow, and if you use, right, now, because nowadays students, they are habituated with writing the Python code, right? And in the Python, there is many more flexibility compared to the other programming languages. So for everything, right, if you want to do this visualization technique or the mathematical function, everything, all the library functions are there. Simply you can use the library functions to outlier, to prevent or to detect the outliers. Sometimes, right, you can apply some methods to handle those outliers also, right? So let me quickly show this, because right, these are having in different programming language, you can follow different syntax to draw the box plot. Suppose you are having some data set and you have drawn the box plot, right? If you see, this is the mean of the data, right? And if you see this right side, these 2 points, these 2 circles, they are significantly deviating from the mean of your data set, right? So those 2 points you can consider as the outlier. So that is the concept of the box plot. You are drawing the box plot, and those points we are having higher deviation from the mean of the data. So this line, this bold line, this represents the mean of the data. So these 2 points you can consider as the outlier in your data set. Second one is the histogram, right? Histogram, what we are doing, we are supposing the x-axis, we are representing the numeric values. Suppose in this example, this is the age of the students, the x-axis, and the y-axis, where frequency, under that group, how many students are belonging to this age group, frequency we are taking, right? If you observe this histogram of this age variable, now if you see this side, this is right, this is deviating significantly from the remaining objects. So mainly this is having, right, this also, it depends upon your domain, which application or which problem you want to solve. Depending upon that, you can give some threshold and you can define which points are outliers in your data set. Third one, you can go for the scatter plot also. So this is the x-axis, you can represent one attribute. Y-axis, you can represent another attribute. You can draw the scatter plot. How the points are scattered, right? If you see in this, right, these points are very close to each other, this side. If you form any clustering also, right, now different clustering techniques also you can follow to identify the outlier from your data set. So if you observe the scatter plot from a given data set like this, so, and depending upon your application, if you see this point, this right corner and this right, this is lower, right, these 2 values, their behavior is significantly different from the remaining object, right? So these 2 points you can consider as the outlier. So it may be in some scenario, right, up to these 5 points also I can consider as the outlier. Again, for this, all right, you're detecting the outlier and how to handle the outlier. For this, you should have the domain knowledge about the problem. If you are having the domain knowledge, then only you can tell that these are the outliers with respect to my data set for solving my problem. Otherwise, it will be very difficult, right? So these are the simple 3 visual technique, your box plot. You can go for the scatter plot. You can go for the histogram, right? Now let us see what are the mathematical functions you have to apply to find out the outlier or to detect the outlier in the given data set. So mathematical score, I think everybody knows the normal distribution, right? We are having the mean and the standard deviation. So the z-score, generally, if you apply the statistics, and the statistics, we are using the z-score, right? So z-score, it helps to understand if a data value is greater or smaller than the mean and how far it is from the mean, right? So mean, we are having the mean, we are having the standard deviation, and how far the data point is from the mean that we are calculating. So for the z-score, you have to use this mathematical function, that is the x is your point you want to detect whether this is an outlier or not. So you have to find out the x minus mu by sigma, that is the x minus mean by standard deviation. And if this is the value is greater than 3, right, that is 3 mean, it is far away from 3 mean, right? That means that point is quite different from the other data points in our data set. And that value we can consider as an outlier. If you say this z-score also, right, then the Python, that standard library is there. Simply you can call this z-score, and what it will do, it will identify, right, or pre-processing, your scalar processing is there also. You can use that one, and it will detect the outliers in your data set. Second one is your interquartile range, or the IQ or score you have to calculate from your data set. So for that, what you have to do, you have to do some mathematical calculation here for your given data to divide the data into 3 quartiles. So quartile 1, this is the lower quartile. Quartile 3 is the upper quartile, and in between there is the quartile 2 also you can determine, right? So it depends upon the median value and the number of elements present in your data set. So if the number of elements are odd, you have to do some calculation. If the number of elements are even, you have to do some calculation. So that calculation you have to follow. Only the median value you have to use. So by using that median and that number of elements, whether even or odd, you have divided the data into 3 quartiles. Now, what you have to do, you have to find out the IQR value, that is the interquartile range. So the IQR value will be Q3 minus Q1. So the higher quartile value minus the lower quartile value, that is the IQR, interquartile range. So which point is said to be the outlier? Now this is the first quartile, lower bound. This is the upper bound. Q3 is the upper bound of our data, right? So if you go beyond this Q1 in the upper level, if a point is present beyond this Q3 plus 1.5 into IQR, that point is said to be outlier. And if you go beyond the lower level, right, the lower bound is Q1, that is the lower quartile. So if any point you are getting, right, this value, beyond this value, Q1 minus 1.5 into IQR, then those points are called the outliers, right? So simply you can find out this IQR score, right, by using this IQR range, IQR value you have to calculate, and depending upon this Q3 plus 1.5 into IQR and Q1 minus 1.5 into IQR, you can handle, or you can able to detect the outliers present beyond the upper level and present beyond the lower level, right? So in this way, right, by using these simple techniques, you can detect the outlier present in the data set. So if you are able to detect the outlier in your data set, now how to prevent these outliers in your data set? So what you have to do with the data set? Once you know that outliers are present, so these are the outliers in my data set. So how to prevent this data points, or how to prevent these outliers in the data set? So as I told, so preventing outlier in a data set completely depends upon the domain knowledge and the experience with the outliers, right? So the domain knowledge is required for preventing this outlier. Otherwise, it will be very difficult, right? Simply, this is the one method. By using the domain knowledge also, you can drop that record from the data set and you can handle that outlier, right? Second one is, you can drop the outlier record. This is very simple, right? If you are getting this, these are the points we are getting this as the outlier. They are deviating significantly from the remaining points. Simply will drop that record. Simply will delete that record from your database, right? But that is not, right, that will not help always. If you are deleting some record from your data, right, what will happen? You will lose some information also, right? So sometimes it is best to completely remove those records from your data set to stop them skewing your analysis. But always it will not support, right? Because you may lose some important information from that outlier record also, right? Third one is, you can cap your outliers data, right? As I told, Hello, am I audible?
Yes, audible. The screen is not shared.
No, I didn't share, madam. I'm sharing.
Okay.
Is it visible?
Yes, visible.
So where were we? Here only in this slide or?
We were here only. In the
Here
slide
only.
only. Cap
Okay.
your
Okay.
outlet data. Okay.
Okay. Thanks. Right. So the third one is we have to cap our outlier data, right? That means at some points, right, their behavior is same with respect to a certain value. So you can cap that value. Then like your CC value I told you above 10, the behavior of program is same, right? So we can cap the higher values with 10 only. That is the cap our outlier data. Next one is we can assign a new value. So the outlier, you can replace a new value with the outlier record, but randomly you cannot assign a new value. For that, you have to do some imputation. So imputation means you have to follow some statistical inference to assign some value to your record, right? So generally the common imputation method include, you can use the mean of a variable or you can utilize a regression model to predict the machine value, right? On the final one, we can go for a transformation, try for a transformation, right? There is min max transformation is there. You can go for min max transformation. There are some arithmetic transformation also there. You can go for exponential, you can go for logarithmic to transform your data from one form to another form, right? So these are the simple things you have to follow once you have, right, detected outlier by using some visualization technique or by applying some mathematical technique. Once you have detected the outlier, you can use these methods to prevent outlier in your data set, which will lead to, right, better training of your machine learning model and your better performance of the machine learning model for your particular problem. Right? Now let us see the second concept, that is the second problem it may happen in the data set, that is the class imbalance issue. Right? So what is the class imbalance issue? Suppose we are trying to solve a problem, a classification problem, right? And there are suppose two classes are there, binary classes are there, and the number of records or the number of instances for both classes, they are deviating significantly, right? So when observation in one class is higher than the observation in another class, so we can call that is a class imbalance issue, right? Suppose I want to predict the number of defects present in a software, right? Suppose, or I want to predict, suppose a software is having 1,000 modules. So out of 1,000 modules, which modules are faulty modules, which modules are non-faulty modules. So this is a binary classification problem. Suppose I have collected data where only, right, 1,000 modules are faulty and 9,000 modules are non-faulty. So there is some biased data is there, right? And this is your imbalanced data. So what will happen if we are having this imbalanced data in our data set? So what will happen? Again, it will hamper the model performance, right? That means you may, your model may not be trained well, or you may not get the better performance of the machine learning model. Then we will see what are the different performance measures we have to use in the machine learning models whenever we are handling with this imbalanced data, right? So whatever I assume some of the students, you know about the machine learning, different machine learning models, because nowadays from BTech third year onwards, your machine learning is there, right? So most machine learning algorithms, they work best when the number of samples in each class are about equal. That means there is no biasness, because whenever you are designing the machine learning model, the variance and the bias, right? You have to trade off between the variance and the bias. So whenever your data set is imbalanced, what will happen? You will get a pretty high accuracy by predicting the majority class, because the biasness is there with respect to the majority samples, but you will fail to capture the minority class, right? As a result, what will happen? You will get better accuracy only, right? Because all the, right, your majority classes you will get 100% accuracy, but your minority classes you will get 0% accuracy, because biasness is towards the majority classes. So accuracy will mislead whenever you are handling with the imbalanced data in a machine learning model, right? Why? You see here overall accuracy you will get high, because most modules are, right, for these non-fault modules you are getting 100% accuracy. You are getting higher accuracy. But for the faulty models, whenever the minority classes you are considering, you are getting 0-point accuracy, right? So this 100% accuracy, why you are getting? Because your model is biased. It is not due to you have designed a very good machine learning model and you have trained your model very well. That's why you are getting 100% accuracy for your majority classes, right? So whenever you are dealing with the class imbalance data, so don't use accuracy as the performance measure, because it will mislead the performance of the machine learning model. So how to overcome this class imbalance issue, right? So there are different imbalance learning approaches are there. Different imbalance learning approach you can follow to balance your data. So I will start, I will take only the basic techniques, so that I will tell what are the disadvantage of this basic techniques, so that nowadays right, more research is going on designing the right oversampling approaches, right? So we'll see what is the oversampling approach and what are the standard oversampling approaches are there, and what are the demerits of those standard oversampling techniques, so that we can go for higher level imbalance learning approach. So generally, if you want to balance your data, you can use the different sampling technique, right? So one is your undersampling, another is your oversampling. So undersampling means you have to remove some samples from the majority classes, right? And the oversampling means you have to add more examples from the minority class. So if you see this, right, this simple example, right, this diagram in the left side, this orange color, it represents the minority class, this blue color represents the majority class, right? So what you have to do in order to balance the data, you have to remove some measured samples from the data set, right? So removing means you are doing the undersampling. So remove some data, some samples from here. It depends upon what is the balanced proportion you want, right? Depending upon that, you can randomly delete some samples from the majority samples, so that you will get a balanced data set. So the reverse happened in the oversampling. Assume this blue color, this is the majority, and this orange color, this is the minority. So you have to add some more samples into the data set with respect to the minority class, right? So what you have to do, you have to add, right, some minority samples into the data set, but that is randomly only. Right? We are not doing any mathematical operation, nothing we are doing. Only the randomly we are selecting some records, randomly we are adding some records into the data set. So what is the advantage? The advantage is, right, there is nothing we are now considering, nothing, only randomly we are choosing the samples from the data set. This is the advantage only. This is very simple. Randomly you can select any one of the sample and you can add or you can delete, right? But what are the disadvantage here, right? So what will happen whenever you will go for the oversampling, right? So what we are doing, we are duplicating the random records from the minority class. So if you are doing duplicating, right, what will happen? It may cause overfitting in the machine learning model. So what is overfitting? Overfitting means your data, right, your training error is very less. You are able to train, but your testing error is very high. That is the overfitting. And if you do the reverse in the undersampling, you are removing the random records from the majority class. So as you are removing some of the records from your data, you may get this loss of information, right? So due to this, right, next year, instead of using this random records for the oversampling or the undersampling, different synthetic sampling techniques are there, in which we are doing some linear interpolation of the original data to add some new data into the data set or to remove some data from the data set, right? So diversity, if you see, the diversity of the data is very less, because diversity will be zero some cases also, because we are duplicating the records. So we'll get very less diverse data whenever you are balancing the data by using this random oversampling or the random oversampling. So in which scenario you can go for the random undersampling? Right, random number sampling. If you have a ton of data, right, you have suppose 3 millions of data points are there. In that scenario, you can go for the undersampling. And in the oversampling, right, if you don't have a ton of data, very less amount of data is there for your problem. In that scenario, you can go for the oversampling. Right. So generally, whenever I used to solve problem, right, in many cases, many scenarios, we used to get very less amount of data, right? So generally, if you see on the, especially for the PG students and the PhD students, right, if you focus, so always if you see the literature, right, and the literature, or everybody or the researchers are trying to all right, design some new oversampling approaches only. You will not get many research papers related to undersampling, right? Because we are assuming many cases we will have small amount of data. So we have to oversample our data. Okay, so one of the undersampling only I will tell, because I have never seen some undersampling approaches in any research papers, because right, nobody is using this undersampling. It depends upon your data size. So to make link, this is a simple undersampling approach. What you have to do, you have to identify the tomic links in your data set. So what is the tomic link? These are the pair of very close instances but of opposite classes. So what you have to do, you have to remove the instances from the majority class of each pair, so that, right, it will increase the space between the two classes, due to which it will facilitate the classification process and you will get better performance from the model. Right? Let us see in this diagram. Suppose this is our original data. Now if you see in the middle point, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 tomic links are there, right? These are the 2 points, they are paired. If you see one from the minority class, orange color is from the minority class, blue is from the majority class. So they are paired each other. So how to identify this pairing? You can go for the Euclidean distance. Depending upon the Euclidean distance, you can identify these 8 pairs, right? Number of pairs, it depends upon the data set. Then what you have to do? You have to remove or you have to undersample the majority classes. Now if you see in this third one, these blue dots, right? Blue dots I have removed from the tomic links. So this is now your balanced data. Now again, depend upon what is the balance proportion you want, right? Depending upon that, those many tomic links you have to identify, and those many majority samples you have to remove from the data set. Okay. So let us quickly discuss about this synthetic minority oversampling technique. So what happens in the oversampling, random oversampling, we have seen that we are selecting the records randomly. That means we are adding the records randomly, due to which we are getting the overfitting. And due to which what we are doing, we are getting the less diverse data. So in order to resolve that issue, your synthetic minority oversampling technique, this is used. So what it is doing, instead of randomly adding the points, new points are generated synthetically. So some linear interpolation you have to do for the minority class, and you have to add those synthetic points inside the data. Now let us see quickly what are the steps. So we see a very simple step, 3 steps are there. So the step 1, you have to identify what are the minority samples, what are the majority samples. Let us assume the minority class set is A, right? So for each instances X belongs to the set A, you find out the k nearest neighbor of X by using the Euclidean distance, right? In the second step, you define the sampling rate N, what is your balanced proportion. So depending upon that N value, what you have to do, you have to, right, for each minority sample belongs to the set A, you have to randomly select, right, from its k nearest neighbors, right? So n examples you are selecting randomly from its k nearest neighbors. So assume that set is A1. Then instead of using those same data points, you have to linearly interpolate between this A and the A1. So simple mathematical equation you have to use here. So for each example, xk belongs to A1, to that neighboring set. So you can use this linear interpolation. So x test, this is the interpolated value or the synthetic value. This equals to the old value, that is the x. Then plus you generate a random number which follows the uniform distribution in the range 0 to 1, multiplied by, right, the deviation between the old point and the new point. So if you apply this linear interpolation, you will get a new set of records. So that problem, right, your overfitting problem, it may be reduced to some extent, and you may get some diverse data after doing this interpolation, right? So this synthetic data you have to generate by using the synthetic minority oversampling technique. So there is another version of SMOT is there, that is the B-SMOT, boundary SMOT, right? So instead of considering all the minority class set A, there you have to identify the boundary instances, because major problem is the boundary, right? In the boundary we are unable to identify whether that instance is belonging to this class or this instance is belonging to that class. So you have to identify the boundary classes by using the Euclidean distance, and same linear interpolation you can use for adding some samples into the data set, right? So this is about the SMOT, that is the synthetic minority oversampling technique. So what is this disadvantage if you apply the SMOT technique to your data set? right? Here also you may observe, right? Even if you are synthetically generating the data, you are adding new data into the data set, right? So the diversity among the data, it may be very less, right? And you are not giving priority to the majority samples, so the minority samples, because you are giving equal weightage to all the instances belongs to the minority class, right? So in order to solve this problem, there is the Adasin approach is there. That is the adaptive synthetic sampling approach for imbalanced learning. So what we are doing here, here we are giving weightage to the minority instances present in our data set, right? So depending upon the weightage, right, different number of sampled instances we have to add. In the SMOT, we have given equal weightage, right? So in Adasin, we are giving different weightage to different instances so that we can assign or you can generate different number of instances into our data set. So how to give us this weight to the instances? Depending upon the level of difficulty in learning, right? We have to identify which points are difficult in learning. So those points we have to give more weightage. So if we are giving more weightage, so more synthetic samples we are going to generate for those difficulty instances only, right? So more synthetic data is generated for the minority class examples that are harder to learn compared to those minority examples that are easier to learn. So what it do, this Adasin, generally it will reduce the bias introduced by the class imbalance, and it will adaptively shift the classification decision boundary towards the difficult examples. Okay? So what are the mathematical steps you have to follow here? Assume we are having the training data DTR with m number of samples, right? Suppose xi, these are the n dimensional features. Yi, this is the class identity level, whether this is a positive, negative class, or right, majority or the minority class, like that, right? So let us assume this MS and the ML, this represents the number of minority class examples and the number of majority class examples. So what is the relation between this MS and ML? So MS should be less than equals to ML because these are the minority classes, and total, the sum of majority and the minority instances should be M. That is the total number of instances. So here what we are doing, we are presetting some threshold value DTH, which represents the maximum tolerated degree of class imbalance ratio. So depending upon this DTS value, we are going to add some synthetic data into our data set. So for the given data, you first calculate the degree of class imbalance, that is D equals to MS, number of minority samples divided by number of majority samples. So always it will come in the range 0 to 1, right? Because your MS is less than equals to ML. So the value of D will be in the range 0 to 1. So we are defining some threshold value DTH, right? If your D value, this class imbalance degree is less than your threshold value, so you have to synthetically add data points into our data set. So how to calculate how many number of synthetic data you need to generate for your minority class? That is suppose capital Z, that equals to number of majority classes, a number of instances in the majority classes ML minus the number of instances in the minority class into beta, where beta is a parameter which regulates the number of synthetic data examples. So beta you can consider in the range 0 to 1. Again, you have to do different types of experiments. You have to analyze for which value of beta you are getting better balanced data, right? Now this is the capital Z is the total number of synthetic data, right? Now what you have to do, you have to assign some weight to each minority sample in the data set. So for each example xi belongs to the minority class, you find out the k nearest neighbors by using the Euclidean distance. Then calculate the ratio Ri for that instance equals to Si by k. So Si is the number of examples in the k nearest neighbors that belongs to the majority class, divided by k is the total number of neighbors, right? So this Ri, if you calculate this one, always you will get the value in the range 0 to 1 also, right? Because total number of neighbors are k, and out of k you are selecting Si, right? Then what you have to do, you have to find out the weightage of that instance. So how to find out the weightage? So Ri, right? You have to normalize this Ri as Ri dash. So Ri divided by sum of right, the values Ri values of all the instances. So this Ri dash, again this way always you will get in the range 0 to 1, which is the weightage of the ith instance, right? So if you know the array dash value, then you can determine how many synthetic instances you have to generate for each minority class in our data set. So the next step, what you have to do, you have to calculate the number of synthetic data examples that need to be generated for each minority class, right? So for ith minority class, how many instances you have to generate? Gi, right? So Gi equals to weightage of the ith instance, that is the array dash, into capital Z, that is the total number of synthetic data you have to generate, right? So once you determine this one, how many number of synthetic data I have to generate for the ith instance, right? You got this value. Simply, you can apply the linear interpolation like your synthetic minority oversampling, and you can add the synthetic data to the corresponding minority samples, right? So for each minority data class example xi, you generate the GI synthetic data using these two steps. And similar to your SMOT only, right? You only one alpha parameter here we are adding. So randomly choose one minority data example from the k nearest neighbor, right? Then you generate the synthetic data by using this interpolation. So the new synthesized data, SI, synthesized data for the ith instance equals to the ith instance xi plus its neighbor xzi minus its old value xi into alpha. Again, alpha is a parameter which follows the uniform distribution in the range 0 to 1. So you can, here also you can do different types of, right? Alpha value you can take in the range 0 to 1 by different value. You can do different types of experiment. So that you can get an idea how it is affecting on the performance of the machine learning model, right? So in this way, you can apply the ADASIN to resolve the class imbalance issue in your data set. If you are having the multi-classification problem, right? I told about the binary classification problem. If you are having the multi-classification problem, so you can go for this mode ADASIN, you can apply, but there you have to do some data decomposition, and you have to do some cost sensitive learning approaches also you can apply to balance the multi-class data also, right? So whenever, right, we are having the imbalanced data when we are applying the machine learning models, right? I told accuracy, it will mislead, right? So don't use accuracy. It is not the best metrics. It is not suggested to use the accuracy for the imbalanced data sets. So you know the confusion matrix, right? From the confusion matrix, you can define this precision, recall, F1 score, area under curve, right? So precision, that is the classifier's exactness, or classifier what in how many positive classes are predicted correctly to the total number of classes, positive classes predicted, right? And the recall, this is the measure of classifier's completeness. So precision is called the true positive rate, recall is called the false positive rate. F1 score, this is the weighted average of precision and recall, right? So F1, your area under curve, that is the hierarchy curve, AUC, simply AUC, it represents, right, the TPR, true positive rate versus the false positive rate. That means your precision versus recall. So it represents the likelihood of the model distinguishing observations from the two classes, right? So generally, if you observe many research papers, you will get this AUC, area under the curve. So generally, this is the, I told you, this is the TPR, true positive rate versus the false positive rate, right? You can use those, always its value will be in the range 0 to 1. So when AUC equals to 1, how to interpret? The classifier is able to perfectly distinguish between all the positive and the negative class points correctly. If AUC equals to 0, that's the reverse. So the classifier would be predicting all negative as positive and all positive as negative, right? So even if the AUC value, right, 0.5 to 1, so always you take the value 0.5 to 1, in the range 0.5 to 1. So there is a high chance that the classifier will be able to distinguish the positive class values from the negative class values. Right? This is because the classifier is able to detect more number of true positives and true negatives than the false negative and the false positive. Right? So what is your requirement that you have to see first? If your AUC equals to 0.5, you are getting, right? That is also, right? That is also not the good model. Then your classifier is not able to distinguish positive and the negative class points. I mean, that means either the classifier is predicting random class or constant class for all the data points, right? So higher the value of the AUC of a classifier, the better its ability to distinguish between the two classes. So generally, always you consider between the 0.5 and 1. If the AUC value is coming, then you can, right, conclude that the imbalance learning approach has some impact on the performance of the machine learning model. Right. So this is all about the performance measure. I think time is over. I have taken more time. Okay. So this is all about your outline on the class imbalance issue. So I told only the basic concepts. So those who are working especially for the PhD level students and the PG level students, right? Because BTech level, they can apply the basic models for the PG and the PhD level students. You can go for the research oriented imbalance learning approaches, right? So you can go for, this is one of our paper, your diversity based imbalance learning approach for software fault prediction using machine learning models. So this is published in Applied Subcomputing. You can go for this approach. That is we have proposed a weighted average, right, centroid based imbalance learning approach, which is better than all the basic your SMOT, ADASIN, oversampling, right, and also some chromosomal theory of inheritance models are also there. So this is giving the better performance. Second one, you can go for this Mohakil. This is also one diversity based oversampling approach to elevate the class imbalance issue. Third one also, you can see some of the data and the algorithm hybrid approach for imbalance data problems in deep neural networks, right? If you see these oversampling approaches, it may help you to solve your problem, right? And if you see, right, all these models now, whatever 3 models, referred models, they will generate the less, right? Your diversity will be more in those synthetic samples, whatever you are generating, right? Already this is verified and statistical test already they have done, right? So you can go through the papers and you can see if it helps for your research problem, right? So this is from my side. If any questions are there, I am ready to accept.
Thank you, Dr. Mangubala. It was very informative. It will definitely help our students, those who want to pursue their research in machine learning. Outliers and class imbalance is really a very big problem in machine learning. To identify the outliers, it's very difficult to find out, and how it is affecting the performance of machine learning models. It has been very clearly discussed. If anyone has questions or any queries, you can ask.
Hello, ma'am.
Yes.
Actually, ma'am, you told that AUC is better for measuring the performance of classification when 2 classes are used. Then more than
Yes.
more than 2 classes will be there. So can we use AUC? There will be some different measure.
You are having more than 1 classes and you are having which type of data, whether you are balanced data or imbalanced data?
Actually, it's some classes are of imbalanced.
Imbalanced data. So imbalanced data, also, yes, you can go for AUC also, no problem. Instead of accuracy, you can go for remaining, right? There are other, your G min is there, MCC is there, you can go, balanced is there, you can go for, except accuracy, you can discuss other metrics, no problem.
Okay. Thank you, ma'am.
Ma'am, we have also a query. Can these model be used in class imbalance problem in image data set?
Which data set, madam? Can you repeat your question?
In the image data set.
Yes, madam. Because image only you have to convert into some numeric value, right, madam? You are extracting the features, numeric values you are extracting from the image. You can apply, madam.
Okay, ma'am. Ma'am, also there is another query that suppose in your text in natural language processing and all, because we have words that vary, they vary according to their context. They have different meanings. So can how we can find the outliers there? Means whether
you
it
see,
is
you
belong.
are having your NLP or natural language words are there, right? You are converting that what to vector is there, right? You are converting
What
that
vector is
to
there?
vector. There you can analyze the numeric values there.
Okay,
There also, yes, it will not work for words, it will work for vectors. Any numeric value, it will work. You have to convert the data into numeric value.
Okay, ma'am. Okay, ma'am, it was really very informative. Some of our listeners want the presentation that the people
Yeah, I will
slides to be
share. I
shared.
will share.
Okay,
I will
ma'am.
share. I will
Thank
share.
you very much, ma'am. So we may end the meeting. Thank you, everyone. Thank you, as our speaker, and thank you, our HOD ma'am, and all those listeners who were listening. So we may finally end our meeting.
Thank you all. Thanks, Sagarika.
Thank you.
Thanks, sir.